Hello everyone, welcome back. So in previous lecture I started about this second portion that was about the linear and angular measurement, and I explained how to take reading on the vernier caliper. Now further moving to today's lecture, the let us say about the vernier height gauge. Now the vernier height gauge here, it is shown in the figure, is another common vernier principle based instrument used for accurate measurements and marking of vertical heights above surface plate datum. So here is the surface. Okay, now this is the workpiece whose height is to be measured. So there is one vertical column, okay, on which we are having the main scale, and this is our base, and it is having another secondary scale, auxiliary scale, or that is called as vernier scale. With the fine adjusting screw we can move this slider up and down, and there is clamping screw that is used to fix at a particular position, and it is having one scribing jaw and bracket. Okay, so this is the bracket which is fixed to this vernier. Okay, moving part, while there is this scribing jaw, with opening this nut we can change this scribing jaw for different type of application. It can be flat, it can be pointed type. Okay, so there are various type of scribing jaw as well as. Okay, and this is the guide surface, and it is in vertical form. It can also be used to measure differences in height by taking vernier scale reading at each height and determining the difference by subtraction. It can be used for number of applications in tool room and inspection department. Like suppose we want to take the difference between height of this two objects. Okay, so this is another secondary object. Now first we measure the height of this object, then we will measure the height of this object. Okay, so after measuring both height we will take the difference, so we can have the difference of height as well. Okay, now let us see about the construction. The vernier height gauge is similar to vernier caliper except that fixed jaw. In this case, it is replaced by fixed base that rests on surface plate or table when taking measurement. The base is massive, robust in construction to ensure rigidity and stability. A vernier graduated column is supported on massive base. The sliding jaw is attached to sliding vernier head, while the sliding vernier head is facilitated with clamping and fine adjustment screws. The sliding jaw carries a removable clamp, and that can carry a measuring jaw or a scriber, while the upper and lower surface of measuring jaw are parallel to the base so that it can be used for measurement over or under a surface. The scriber, when attached, the vernier is used for inspection of parts and for layout work. The scriber can be used for scribing lines at a specified distance above the surface. The scriber may be, in some cases, be replaced by a dial indicator. Instead of scriber, there can be a dial indicator. This provide an edge and exact reading of slider movement by dial gauges, which is larger and clear. All parts of gauges are made of good quality steel or stainless steel. Now, what are the certain precautions to be taken in use for vernier height gauge? So, first thing, the height gauge should be kept in its case when not in use. When we are not using it, we have to put in a case. Okay, it should be tested for straightness, squareness, parallelism of working face of beam, measuring jaw, and scriber. There are three main things, that is the vertical, that is the beam, then measuring jaw, and scriber. So the straightness, flatness, and parallelism of these three must be checked before proceeding for any testing purpose. When using a gauge, care must be taken to ensure that the base is clean and free from burrs, which means before measuring, we have to ensure that the base is clear and free from burrs. If there is any burrs below the workpiece, then there will be possibility of error in measured height. Or we are using gauge, so there can be possible error. Then springing of measuring jaw should be avoided. Okay. Sometimes what happens, we tight the nut very, or we move it very down, so it, when we take off the workpiece, or it jumps. So measuring jaw should not jump or suddenly should not strike to the workpiece. Okay. For taking a final reading, sliding jaw should be locked to vernier column by locking the screw. So the final reading, we have to, the sliding jaw should be locked to vertical column by locking screw. So before taking reading, first lock it and then take the reading. Now another is instrument is vernier depth gauge. The fine adjustment screw, vernier scales, a vernier depth gauge, here it is shown in the figure, used for measuring depths of holes, slots, recesses, and distances from a plane surface to projection. Okay, so here you can see the vernier depth gauge. This is the depth to be measured, and this is our hollow workpiece. It can have hole, slot, recess, or distance from a particular plane surface to projection, that we can measure with the help of vernier depth gauge. Now here, the all the other part is more or less same to the vernier height gauge, but the difference is only in the design of this movable head, which is having this flange on the both side, and this is the vernier scale. Similarly, fine adjusting screw, clamping screw, these are the clamping screw, this is the main scale, and this is the guide surface. It consists of a vernier scale and main scale. Vernier scale is graduated on to the main body of depth gauge, and the main scale is graduated on a long blade on which the sliding head of vernier scale slides. The gauge also having fine adjustment and locking screw. While using the depth gauge, the base is held firmly on reference surface. Before using a gauge, the first of all, make sure that the reference surface on which the depth gauge base is rest is satisfactorily true, flat and square, which means this surface should be flat and It should be free from bars, okay, and it should be square. Then the lower the blade into the hole until it contacts the bottom surface of the hole. Then we have to lower this blade, okay, so that we can measure the depth. The final adjustment depend upon the sense of contact feel is made by the fine adjustment screw. The final adjustment is done by the sense of contact by the fine adjustment screw. Sliding head locks on the blade or the main scale. By tightening the locking screw, the instrument is removed from the hole and reading taken from the main scale and vernier scale for same way as we do in the vernier caliper. So the reading taking procedure is same. The depth gauge, sliding head, and long blade are made from good quality steel or stainless steel. It is carefully made so that the blade is perpendicular to the base in both directions and the ends of the beam is square and flat like the end of a steel rule, and the base is flat and true, free from curves or waviness. Another instrument very much important and mostly used for measuring the diameters as well as, okay, thickness, we can say, that is the micrometer. Now a micrometer is very useful device for magnifying small measurements. In micrometer, the accurate screw and nut are used for measurement. The micrometer having good accuracy, about 0.01 mm, hence is used for most engineering precision work. Okay, so they are having the very good accuracy. Now, what is the principle of micrometer? The micrometers works on the principle of screw and nut. So the screw is attached to a concentric cylinder or thimble, the circumference of which is divided into number of equal parts. Okay, so there is screw which is attached to concentric cylinder or thimble, the circumference of which is divided into number of equal parts. We know that when a screw is turned through a nut by one revolution, its axial moment is equal to the pitch of thread of the screw. So as we turn the nut by one revolution, there will be axial moment and that will be equal to the pitch of thread of the screw. If 1 mm pitch or lead of screw in mm, each revolution of screw advances it in relation to the interval thread a distance equal to 1 mm. If the circumference of concentric cylinder is divided into n equal divisions, movement rotation of cylinder through one division indicate 1 by n rotation of the screw or 1 by n mm axial advance. So जब 1 mm एडवांसमेंट होगा, ठीक है, of pitch or lead of screw in mm, each rotation of screw advances in relation to the internal threads a distance which is equal to 1 mm, and the circumference of concentric cylinder is divided into n number of divisions, okay, suppose say 50 or 100. Okay, so the movement of cylinder through one division indicate 1 by n, which means 1 by 50 or 1 by 100 rotation of the screw or 1 by n mm axial advance. So in millimeter micrometer instrument, the screw has a pitch of 0.5 mm. Here instead of 1 mm, the millimeter micrometer having 0.5 mm of lead, and thimble has 50 division. So the least count is equal to this 0.5 divided by 50, which means one rotation is divided into 50 division. Okay, so one rotation advance is equal to zero point 0.5 mm. Okay, so here it is 0.01 mm it will be. So this is the list count of micrometer. By reducing the pitch of the screw, the thread, or by increasing the number of division on thimble, the axial advance value per one circumferential division can be reduced and accuracy of measurement can be increased. So this is the all about the principle of micrometer. Now let us see the construction. So here it is the complete figure of micrometer. It shows the outside micrometer used for measure the outside diameter with accuracy of 0.01 mm, and it consists of a U-shaped frame. Here you can see this is a U-shaped frame. There is anvil. This is the fixed anvil. Okay, and there is spindle. This is the spindle which is the movable. Then there is thimble. Okay, so this is the thimble with auxiliary scale, and inside thimble there will be the screw. Okay, which is makes the axial advance of this spindle, and there will be barrel or sleeve. Here it is the barrel. Okay, or sleeve, and there will be also ratchet for moving it very slowly, and the dimension to be measured we can measure over here. And there is also lock nut, and here it is the lock nut which is used for locking it. The U-shaped frame made of steel or cast iron or light alloy and holds all the component of micrometer. The gap between two ends of the U-shaped frame permit a maximum diameter or length of job to be measured. Will be huge frame, and that will be very useful for, and the gap between that will be permissive, permitting the maximum measurement of the diameter or length of the job. The one end of the spindle is attached to the thimble, and the other end constitute a movable the movable anvil and the screw thread made on the spindle with a specified pitch. One end of the spindle is attached to the thimble, okay, and the other end constitutes the movable anvil. There will be movable anvil. Here it is, okay. Now the screw thread made on the spindle with specified pitch. The screw threaded spindle passes the barrel, which acts as a nut to engage the screw thread. Okay. Now the fixed anvil is fixed on the left side of the U-shaped frame. So here it is the on the left side, and which is fixed. Barrel is accurately divided and clearly marked in 0.5 mm division along with its length, which सर्व्स एज मेन स्केल. सो जो मेन स्केल है वहां पे जो डिवीजन है 0.5 के डिवीजन हो गए, 1 mm के नहीं लेकिन 0.5 के डिवीजन है. देख रहे हो आप यहाँ पे 0 to 10 there will be equal division and it will be also divided in the half. So 0.5 mm for the main scale, and there will be 50 division on the thimble. Thimble can be moved over the barrel when it rotates with screw thread spindle during the axial advance of spindle. So the thimble has 50 equal division around its circumference. Here you can see there will be 50 equal divisions. Now the construction, the each division here you can see having a value of 0.5 mm divided by 50 is equal to 0.01 mm, and the job to be measured here we can fix the job over here is located between the fixed anvil and the end spindle. Okay, when the anvil and the spindle ends are brought together, the instrument reads 0. When this is connected with this surface, it will be showing 0 result over here, and the ratchet is provided over here. The ratchet is provided at the end of thimble. It is used to assure accurate measurement and to prevent the too much pressure being applied to the micrometer. There will be a sound when the spindle touches the workpiece perfectly, and after that we have to stop. Okay, when the spindle ratchet nears the workpiece surface to be measured, the operator uses the ratchet screw. Ratchet screw is used to tighten the thimble. The ratchet automatically slips when the correct or uniform pressure is applied, as I said, and prevents application of too much pressure. A lock nut is provided on the micrometer spindle to lock it when the micrometer is at its correct reading. Now procedure for measuring dimension with help of micrometer. So there is one micrometer we have to measure. This is a cylindrical job we are supposed to measure. First to check the zero error, that is the basic thing. It can be checked by contacting the face of anvil and spindle. The zero on the thimble should coincide with the zero on the reference line on barrel or main scale as in the figure. If this does not happen, then the zero error is present in the micrometer, which must be accounted for in final reading. Hold the workpiece which dimension to be measured. Here this is how the zero error is checked, and between the spindle and anvil the workpiece is fixed. Then make a final adjustment by ratchet and lock nut it with help of job nut. Okay, now take the reading. Okay, we have to take the reading on the main scale. Suppose the main scale reading over here is just suppose 13, and take the thimble reading. So thimble reading is over here, it is 35th division, coincide with the reference line. So the total reading is equal to main scale reading over here, the main scale reading and the thimble reading. So main scale plus least count into reading on thimble. Okay, so reading on thimble is 35 and this count is 0.01. Okay, and main scale reading is here the 13. Okay, so it will be 13 plus 0.01 into 35, so it will be 13.850 mm. So this is how we use micrometer. This is it for today's lecture. Thank you very much for listening me carefully. Have a nice day.